Before we do integration of Trigo, make sure your basic differentiation and integration of Trigo are good, okay? In the sense that you know that differentiate sine will become cosine. Now, when we differentiate, right, we will always need to multiply by the differentiated of the angle. Something like, oh, if I d dx cos of x squared, I'm going to get differentiate cosine is negative sine. Angle will never change. I need to multiply by the differentiated of x squared, which is 2x, and then I'm going to write negative 2x sine x squared. So if you understand this differentiation, you get differentiate this, I get this. Then when we do integration, it's a lot easier. Okay, but before that, let's go through. Differentiate sine, I get cosine. Differentiate cosine, I get negative sine. Differentiate tangent, I get secant squared. So when I integrate cosine, be careful. The number one mistake students do is when they integrate cosine, they go and say it's negative sine. But it's not. It's just going to be equals to sine. When we integrate sine, we integrate negative of sine, it's going to get cosine. So that's why we always say, oh, what happens when we integrate of sine ax? I'm just going to get 1 over a. Negative cosine, because integrate sine is negative cosine ax, and then plus c. Then all you need to do is to make it nice. Okay, so you can only integrate secant square, because differentiate tangent, I get secant square. Integrate secant square, I get tangent. What happens if you need to integrate tangent square? Then you need to apply your Trigo, basic Trigo identity. Tangent square is equals to secant square x minus 1, then you can integrate. Later I'll talk about this. Okay, now differentiation of secant, differentiation of cosecant is actually given in your formula sheet. There you can see differentiate cosecant, differentiate secant, but all these are just in terms of x. So remember, when you need to differentiate a trigo with an angle, d dx secant x squared, I'm going to get 2x secant x squared cosecant x squared. The angle will never change, so the basic angle will still be the same, and that is based on this. Now what you are not given is, what if you need to differentiate cotangent x? Okay, so we know that differentiate tangent is secant square. Differentiate cotangent is negative cosecant square x. One trick I remember is when I differentiate anything with c, there's always a negative. When I differentiate anything with c, there's always a negative. When I differentiate anything with c, I'm going to get 1 over a negative sine ax. Okay, so make sure you know your differentiation very well first before we can do integration. Now, with regards to integration of trigo that is weird, for example, now the first one will just be simple integration of 6 secant square, the 6 put on the outside, secant square, I'm just going to get 6 tangent x plus c, because differentiate tangent, I'm going to get secant square. So if you know or differentiate what to get what, then when you do others, it's going to be easier, like this. Look at c, integral of 2x cubed sine x to the power of 4 plus 1 dx. So this is a result of a differentiation. What do you need to think of? Okay, first, what do I differentiate to get sine? I need to differentiate cosine. Angle will never change. Okay, so when I differentiate this, what am I going to get? Differentiate cosine, negative sine. The angle will still be there. Okay, times differentiated of the angle, I'll get 4x cubed. So I need to be accompanied by a 4x cubed on the outside, because when I integrate this whole thing, when I integrate this, what am I supposed to get? I'm supposed to get this guy only. So it's just like your technique number 1, f prime x, fx to the power of n. You need to pair with the f prime x on the outside. So to make it equal, it's good to have this part as you're working on the outside. I need to have negative 4x cubed sine x to the power of 4 plus 1, okay, on the inside. Are these two equal? They are not equal. So to compensate, to make it to become 2, I need to have a negative 1 over 2 on the outside, so that step 1 and step 2 are the same. Okay, so now that I know I differentiate Mr. A, I'm going to get Mr. B. When I integrate Mr. B, I'm going to go back Mr. A. So my answer would just be straightforward. Cosine x to the power of 4 plus 1. Okay, and that's all, you know, plus C. So anything that's on the outside, don't be afraid. Think of I differentiate what, I can get this as a result. Same thing for D. If I want to, I'm going to write it here, integrate e to the power of x, cosine e to the power of x. So I look at the angle is e to the power of x, right? Now, differentiate what, I get cosine. Differentiate sine. Angle will never change. I'm going to get cosine e to the power of x. I'm going to multiply by the differentiated of the angle on the outside, e to the power of x. That's where I get e to the power of x, cosine e to the power of x, which is exactly as the question. So when I integrate this, who do I get? I'm just going to get back him. So my straightforward answer would just be sine e to the power of x plus c. If you, like I say in my previous videos, you have to understand integration as a reverse of differentiation. Then it's easy to do for all these kind of trigo functions.